Hey guys, as I have mentioned earlier, I will be taking free online coaching classes for the students who are preparing for the JAM examination. For that, I had prepared a lesson plan in which I will cover one heading in a video. At the end of the video, I will be asking few questions from the previous year examinations. And after getting sufficient number of answers from you through comment box, I will repeat the same process for the other topic. Welcome to my channel Success Guru and myself Panchanadam, and this is lecture 1 in which I will be covering the plate tectonic boundaries, and the book which I had referred is The Global Tectonics by Kerry and Wine. So let's get into the topic. According to the plate tectonic theory, the lithosphere is divided into interlocking network of blocks that is termed as the plates. And the movement of plate is driven by the convention in underlying hot and viscous mantle. So if you see, this is a plate. So this consists of the crust and the upper portion of the mantle. These two combine to form the lithosphere. And you know the lithosphere is a solid, that is rock, and the asthenosphere is in molten state. Okay. So these two is in contact in this region in which there is a temperature difference, and you know when there is a contact of two different temperatures, there is a loss of heat, which we used to call it as conduction. So here, due to conduction, the heat losses from mantle to the lithosphere, right? And the mantle is in molten state, which is somewhat near liquid, and it can move. And what happened, this mantle in this portion, the temperature is low when compared to this portion, and where there is a drop of temperature, you know what happens, the density rises. So in a single phase, what happens here, low temperature and high density material, and in this portion comparatively high temperature and low density material. So this leads to convection. So the hot and low dense material try to move up, the same way the cold and high density material try to move down. And as this is highly viscous, the movement will be very slow, but it will also try to drag the plate that lies above this. So this dragging leads to the movement of plate. That is what they are mentioned here. So the convection in the mantle is the reason for the movement of these plates. When this convection were acting away from each other, there will be a divergent boundary that we will call as ridge. When this convection were acting towards each other, there will be a trench. And the boundaries of plate takes three forms. So these are the three forms. One is the convergence, where two plates collides each other, moves towards each other, and this is a divergence, where two plates move away from each other, and this is a transform fault, where the two plates side pass each other. And there are almost 7 to 8 major plates in the world, and the movement varies from 0 to 100 millimeter per year. And the reason for the studying the plate boundary is the earthquake, the volcanic activity, the mountain building movement, as well as the oceanic trenches form along the plate boundary. So it is important to study about this. So let's get into the type of the plate boundary. The type 1 is the conservative plate boundary, that is called as the transform fault, or marked by the tangential movement. The movement will be tangential, that is side pass each other, in which the adjacent plate is relative motion, undergoes neither destruction nor construction. So there will be no construction nor destruction. So that is called as the conservative plate boundary. Okay, and Wilson proposed that the fault terminates at the end of the ridge or trench. So this is not running for a long distance. This will run for a short distance. So it may ends at a trench or it may ends at a ridge. The lateral displacement across the fault is taken up by transform it into either formation of new lithosphere or termination of the older one. Hence it is called as transform fault. So this transforms a plate towards from the origin towards the end. That is what they want to say. And the example, one of the example is that San Andreas Fault, and we had seen a video on 60 seconds fact video about the San Andreas Fault. You can check it in my video list. And there is also one other type of fault which is called as transcurrent fault, which we should not get confused with the transform fault. These two are two different. The transcurrent fault, or also called as a strike slip fault, which is sinistral in movement and it continues for a long distance, whereas a transform fault is in dextral movement and it will move from ridge to ridge. So this is image which shows transform fault and transcurrent fault, where transform fault belongs to the plate boundaries, whereas transcurrent fault will not come under this heading. So this is sinistral movement, that is anti-clockwise movement, and this is a clockwise movement, that is also called as a dextral movement. So this transcurrent fault will not be get confused with the transform fault, and that's why I am explaining this in here. So the conservative plate boundary only deals with the transform fault. The transcurrent fault will not come under this heading. Okay, so this is the type 1. I think you are clear with this, right? And the next one is the type 2, in which accretion or construction boundary. So accretion boundary or construction boundary will come under this heading. So what happens, there will be formation of the divergent plate boundary is a linear feature that exists between two tectonic plates, okay, that are moving away from each other. So this is a divergent boundary in which the two plates moving away from each other. If it is under the ocean, it is called as mid-oceanic ridge, and if it is under the continent, then it is called as continental rift. Okay, they represents the longest linear uplift feature of the Earth's surface. So if you want to see which is the longest linear uplift feature, then it will be the divergent plate boundary, and can traced by a belt of shallow focus earthquake. So the mid-oceanic ridge is the source for the shallow focus earthquake that occurs all over the world. The length may be approximately 55,000 km and the crest are commonly 2 to 3 km above the neighboring oceanic basin. It may be in the middle of the abyssal plain and its height is 2 to 3 meter above the neighboring oceanic basin, and it may be the magma and depleted mantle upwell between the separating plate that gives rise to the new oceanic lithosphere. As we had seen earlier, due to the convection current in the asthenosphere, the molten material moves away from each other, that leads to the divergent plate boundary. Okay, the divergent boundary within the continent initially produces rift. So this divergent boundary, if it is in a continent portion, that will produce a rift valley. If it continues, eventually become a rift valley, and if it continues, eventually become a sea, and if it continues for prolonged time, that will become a mid-oceanic ridge. So these are the three different stages from continent side to the ocean. Okay, the divergent boundary within the continent initially produces rift, which eventually become rift valley. Most active divergent plate boundary occur between oceanic plate and exist as a mid-oceanic ridge. So if it is most active, this may reach up to this level, and if it is not that much active, this will stop at this level itself. That is what they want to say. The rocks which is closer to this boundary will be younger when compared to the rocks that are far away from this. So that is what they are mentioned here. The rock increases increasingly older. So this will be newer one. As we move further, it will be younger one. I think we had solved a question according to like this in the net question paper, right? If you want to see, you can check this in my playlist, the solution for the net exams, right? And the next is the destructive plate boundary. The first one, type 1, is the transform fault. The second one is the divergent, and the third one is the convergent. That is also called as the destructive plate boundary. A convergent boundary is an area on the Earth where two or more lithosphere plate collides. So, in the first one we said neither creation nor destruction. The second one we said there is a creation of new plate, and in this one there is a destruction of existing plate. That is what it is happening. So, one plate eventually slides beneath the other, causing process known as the subduction. So this process is known as the subduction, and the subduction zone can be defined by the plane where many earthquake occurs, and that zone is called as the Benioffzone. So where the plate subducts, so this zone is called as the Benioff zone. Okay. And convergent boundary occur between ocean lithosphere. So there are three possibilities. One is convergence between ocean, the other is continent, the third is ocean continent. These are the three possibilities of convergence. Okay. The geological features related to the convergent boundary vary on the crustal type. So what are the features that are occurring in the ocean convergence may not be here in the continent and may differ from this the ocean continent. So the features that are produced in this convergence, that is depend on the type of the crust that involves. Okay. Since the Earth is not expanding significantly, the rate of lithosphere destruction at the trench must be virtually the same as the rate of creation at the oceanic ridge. So, as we said in type 2, there is a creation of new lithosphere. So, this should be destructed at the same rate here. If it is not, then the earth will be expanding, right? So the earth is actually not expanding, so the rate of construction should be equal to the rate of destruction. And all the intermediate and deep focus earthquake is associated with the destructive plate margin. So whatever the earthquakes that is having deep focus or intermediate focus, that will be originated from this type of boundary, that is called the destructive plate boundary. So let's take first two one type, and we will see the one other next. The first is the ocean collision, and the next is the ocean continent collision. We are seeing both together because many features resembles in both this case. That's why we are seeing it together. The first one is the oceanic trench, or the direct manifestation of under-thrusting oceanic lithosphere and are developed on the oceanward side. So when there is a oceanic trench, that directly indicates that is the under-thrusting of oceanic lithosphere is taking place. Okay, they represent the largest linear depression, as we had mentioned in the mid-oceanic ridge, that shows the largest elevated portion. This will be the largest linear depression feature on the Earth's surface, and are remarkably for the depth and continuity. So they have great depths and they continue for a long distance. The Peru-Chile Trench is somewhat near 4,500 km long and reach a depth of 2 to 4 km below the surrounding ocean floor. So that its base is 7 to 8 km below the mean sea level. So this is an example of length, breadth and width of the trench, where the length is 4,500 km and the depth is 2 to 4 kilometer, and the deepest one is the Mariana Trench, that is somewhat near 10 to 11 kilometer from the surrounding region. Okay, the main control of the maximum depth of a particular trench would appear to be the age of the oceanic lithosphere being subducted. So according to the age of the subducting lithosphere, the depths are fixed. So if it is say deepest, say 10 to 11 kilometer, that may be of different age, and if the depth is 2 to 4 kilometer, that may be of different age. So the age defines the depth of the trench. The trenches are generally 50 to 100 kilometer wide. The width is somewhat 50 to 100 kilometer, and its cross section looks like V shape, which is asymmetrical. So you can see this is almost a V shape, but that is not symmetrical, that is asymmetrical. And the steepest side having a gradient of 8 to 20 degree. Okay, and we are saying about the trench, there is a depression that is V shape. So the depression may be or may not be filled with the sediments. and that is totally depend on the supply of sediments from the adjacent continental area. So if there is a lot of river running and bringing lots of sediments, there will be a big deposit of sediments in this place. If there is no any river, there will be no much sediments. So the trench will be having no sediments. Okay, so that is what they are saying. And while comparing these two, you can say the island arc system are formed when the oceanic lithosphere is subducted beneath the oceanic lithosphere. So when the collision is between ocean, the feature that is formed is called as an island arc. In the same case, in ocean continent collision, there will be called as magmatic arc, and there is also the formation of fold mountain. So this is the difference between ocean collision and ocean continent collision. And there are also some other features like a volcanic arc, that is a curved chain of volcanoes located on a tectonic plate margin. Okay, this is typically with a deep oceanic trench on the convex side. If ocean collisions takes place, that we would call as island arc system. If ocean continent collision takes place, that we used to call it as magmatic arc system. Okay, so these are the first structure in this, and as we move, this is called as the four arc basin. In this also, this is called as the four arc basin. So what is the four arc basin? Is a region between the oceanic trench and the associated volcanic arc. So this is the oceanic trench and this is the associated volcanic arc. So this portion is termed as the four arc basin. So the term four arc basin, the structured four-arc basin is present in both ocean collision as well ocean continent collision. A four-arc basin is a region between the oceanic trench and the associated volcanic arc. The four-arc region are found at the convergent margin and includes any accretionary wedge. So this four-arc basin consists of sediment that is called as accretionary wedge that I mentioned here, right? And the accretionary wedge is oceanic crust sediment that have been separated off the downgoing slab by leading edge of the overriding plate. So if these two plates, say let's take this example, these two plates were colliding, so there will be sediments over this plate, right? So when the crust is moving down, the sediments will not move along with the crust because there is a high pressure zone. So what happens? The sediments which is present here were staying at this position itself, that is scrapped by the crust in this side, and they form as wedge shape, and that is why we are calling it as accretionary wedge. So this is full of the sediments that is deposited on the oceanic floor, right? So when one oceanic floor is moves under the other crust, that will be oceanic or continental, and when the movement there is a sediment over this crust, and that sediment were accreted over here, and it is called as accretionary wedge. You got it? That is the name's reason. As we used to call it as a fore-arc basin, the back side is called as the back arc basin. So from the arc to the continental side, this portion is called as back arc basin, and this will be only in ocean collision. When there is ocean continent collision, this portion is called as back arc thrust belt, where here it is called as back arc basin. That is the difference. Okay. So when two oceanic plate collides, there will be formation of the back arc basin. When there is a ocean continent collision, there will be forming of the back thrust belt. And the third one is the continent collision. So remember, when there is a divergent boundary, that could be on the oceanic floor or on the continent, that is not an issue. But when there is a convergence, there will be no, all of a sudden there will be two continents that will not hit one another. So the first stage is that will be like this one, that ocean collision, that is followed by ocean continent collision, and then what happens, there may be other continent here, so this will come near this and both will collide together. That is what they are mentioned here. So the collisional mountain ridge forms some of the most spectacular and dominant feature on the surface of the earth. So we know that the divergent boundaries forms the depression linear feature, and convergent boundaries form the upthrust linear feature in this thing, right? The example includes the Himalayan Tibetan orogeny, in which the Indian Eurasian collision was brought about by the rifting of India from Africa and East Antarctica during the Mesozoic and by its migration northward as the interesting intervening ocean lithosphere was subducted. So the Indian plate was moving from here. So there was a Tethys Ocean. So what happened to this Tethys Ocean? This was subducted under the continental crust. This subduction continues till the continent-continent collision takes place. When the two continental plate collides, neither of this will go down. The two continent crust collides, neither subduction due to the buoyancy of the crust. As these two have almost same density, nothing will move down. Before that, there was a oceanic lithosphere, and here it is a continental lithosphere. So what happens? The oceanic lithosphere is denser than the continent one. So the oceanic lithosphere tends to move down. But when two continents collides, there will be nothing moves down. So neither subduct due to the buoyancy of the crust, and there will be a formation of the mountain. This is how the continent collision takes place. And this the center, what do you call, during the collision there will be mountain at the where before there was a trench, that is what we are mentioning. In this portion there is no trench, there is formation of mountain, and under this mountain there is a formation of batholith. There is an intrusion from the igneous mantle. There will be no much volcanism in this region. Okay, that is what in this thing. And the next thing what I already mentioned is I will be asking few questions from the previous year question, right? So these are the few questions. There are almost 6 questions from 2020 to 2016, and every year there is a question from this plate boundaries. The first one is from Jan 2020. A trench is founded. They had given the question. They had given 4 answers. And if you want to see this questions, I had given a link in my description, so you can just download the question and see the questions. And this will be my plan for coaching class for the JAM exam. According to your response, we will move further, and you can mention the answer in the comment section. In my next video description, I will be uploading the answer for the 6 questions. Is that clear? So according to your response, you will move further. If there is much replies for this question, I will be happy and we will be doing sooner the next video. Okay. If you still have any doubt, feel free to mention it in the comment section, or you can also mail me your questions. I have grouped my videos to different playlists, so you can check the playlist to find some of my earlier videos. If you like my video, give me a thumbs up. If you feel that this will be useful for someone else, consider sharing. And if you want to see such a video regularly, consider subscribing. Thanks for watching. Have a great day.